Hello everyone and welcome to the start of a new project. This is a Gardner 6LXB. The engine itself is originally out of a truck, but as you can see this has been in a boat. This project's going to be a bit different because this isn't a worn out engine. It was actually supplied by another engine builder as a reconditioned engine to the customer who owns the boat that this is in. Unfortunately, it has been plagued by various issues and now has failed and appears to, according to the owner, have a failed big end bearing. So it's here with us for us to strip and investigate to see what's wrong with it and hopefully get it rebuilt so it can go back in its boat. And as if by magic, it's now in the workshop. So before we begin, we're going to have a quick look around the engine because having a quick nose at it, there's a number of things that are not right just on the exterior of the engine. So have a quick look around, and then the first job we're going to do is get the gearbox off because the owner wants to get that looked at separately, so that's going to come off and get sent away. So issues with the engine before we even start dismantling it. Now, first really noticeable one is this mess here. It's had a flexible hose made up to connect between the fuel pipe on the injector pumps and the fuel filter. But this is bent sharp at 90 degrees here and here, which is all but pinching off the fuel supply. So that'll need correcting and remaking. We'll make a new bit of copper pipe from the T-union that's back that way, all the way back up to here to sort that out. Also, on this side of the engine, because it was an automotive engine, it would have had an air compressor here. This is a drain hole for oil out the bottom of the air compressor, and it's not been plugged, so there's an open hole straight into the crankcase, and if you can see all of the crap and snot that's on the top of here, that means any of that would have gone straight down that hole inside the engine, so that needs dealing with. Obviously it's supposed to be reconditioned, but the bush in here for the throttle arm is knackered. There's a load of play in it here, so I expect when we take this to bits, either the shaft or the bush is worn out, and that will need sorting out. You'll also notice it's got quite a shiny pump here. So I mentioned earlier that the owner was having various problems with the engine from the offset. One of them was that this pump was that was there originally was utterly worn out and wasn't shifting oil, so the owners had to replace this. They've also had to put a set of injectors in it. This side of the engine, another item that's not great is this pipe here has been hit or thumped at some point, and this is nearly squashed flat, and this is the main oil feed from the oil pump to the oil filter assembly, so that won't be doing your oil flow much good, so this will need replacing. And then coming on to the gearbox, the owner's been having gear engagement problems with the gearbox, and I might be wrong, but having a quick look through the schematics in the manual, this gearbox has a PTO and trolling valve fitted. And this pipe here, which is currently teed in, shouldn't be teed in here. It should be in this port here. So there's a plumbing error on that one. And then coming around the far side of the engine, and we've spotted this on another engine we did the other day, is someone has put it together with nuts under the clamps for the manifolds, and that is because these manifolds are off of an LW. They're not for an LXB, and actually the space between the distance between the manifold face and this face where the clamp goes is different between the two models. So as much as it physically fits on in the sense of the number of ports, the internal bore sizes, etc. are different, because obviously there's a higher horsepower engine, the LXBs, and need a bit more air. So as much as they're bolted on, they've been bodged up a little bit to get them to fit. So have to have a discussion with the customer as to whether he's happy to leave this like this or whether he wants them changing out for what should be here. And then from externally, that's about all we've spotted so far. So we'll get straight into it, get the gearbox off and out the way. And as you've only recently watched us take an LXB to bits, we will just start taking it to bits. And if we come across anything that is broken or inconsistent with an engine that's been reconditioned, we'll stop and give you a closer look. So we'll get on now. So first issue we found, we've just thought we best check whether this had been emptied of oil before it came to us, as we're about to stick it on a pallet. The gearbox was still full of oil. The oil is actually very grey metallic sort of paste in it, and initially when it started coming out it was quite metallic-y, quite a few shiny bits in it. And here you go, this is what's on the bung out the gearbox. So quite a lot of metal filings and gunge, and as I say, the oil is very black. So considering the gearbox has only been used for 80 hours, something is not very happy. Okay, so before we take the bolts out the top of the bell housing, we're going to reposition the engine slightly to take the weight of the gearbox. Not a massive issue, but every one of these bolts is a different size head pretty much. Some are Whitworth, some are UNF. Right, last bolt. Got the weight. Yeah, see that one needs a bigger socket. That one's cross-threaded. Okay, so just double check that I've got them all out, and then we'll try and take that off the back of the engine. So with the gearbox out the way, we've got our first look at the drive plate for the gearbox. Now this is an R&D drive plate. I would say from the look of the amount of grime and grot on this and corrosion over all of this, this isn't a drive plate that's only done 80 hours. This has been here for some time, or at least in use for some time. You can also see a nice straight line across the drive plate that way. So at some point, wherever this was installed, that would have been at the bottom, and there'd been a water level up to at least there. Now, on these drive plates, this section is bolted to the flywheel. This section floats in the middle of it, and this polymer portion is what is used to damp the torsional vibration between the engine and the gearbox. So this part here should be able to rotate a bit within the limits of what this will allow. However, if I do this, there we go, so that's it locked against the other bar. This centre portion is absolutely solid. So when we get this off, I expect we'll find that this is seized in to this plate. Again, there's the back of the drive plate. So you look at the levels of corrosion on that. That certainly wasn't new 80 hours ago. Okay, so now we've got the gearbox off and the drive plate out the way. Next job is we're going to strip this side of the engine, so get the starter motor off, manifolds, water pump. As I said before, you've seen us do this on a LXB in previous videos, so we'll rattle through it. If we find anything, we'll stop and show you. The only thing we've spotted this side, since I sort of ran through issues, is there should be a collar between the starter motor and the bell housing that sets the depth of the pinion in relation to the flywheel. That is missing, so at the moment you could unbolt that starter motor, and if the gearbox is there, if a gearbox or bell housing is there, you wouldn't be able to see the depth of the starter motor or get the pinion to flywheel clearance correct. So that'll need a ring making up. Also, this starter motor is a U6 starter motor. The most common starter motor variant on these is the later SL5 type starter motors. So this, not necessarily the wrong starter motor, but not the one that's normal for this this model. So anyway, we'll get all of this stripped off. If we'll find anything, we'll stop and go into a bit more detail. Okay, so with the starter motor removed, I've just spotted something that's made me giggle a little bit. So, next job, just to get this side of the engine stripped, would be to take this strap off, that's the starter motor strap, and this stud that obviously is what secures the starter motor to the engine. So, normally I'd have to take the split pins out, you know, pair of pliers, and straighten them out and pull them out the hole. But in this case, I can go like that because it's not been bent over. So that should just come off of me fingers, no tools required. And the same for the stud up here. Again, split pin hasn't been bent over, so I can remove all of that with no tools. Okay, so we'll open up the water pump and get the top water rail off. No gasket there, just stuck on with instant gasket. Okay, so we've got rid of all the bits and pieces off the other side. There wasn't anything else particularly worthy of note, other than the engine's clearly not had antifreeze in it. Very dirty, corrosion-filled water, the little bits that were left in the water pump. Anyway, this is the first look inside the top end. That's certainly not 80 hours worth of muck. And it appears that it's had service exchange cylinder heads, but there is still a hell of a lot of muck and muck down in there. So anyway, we'll get all the pipe work off and head towards getting ready to lift the cylinder heads off. So that injector appears to be a little loose. It was rotating in the hole, so that might not have been helping for oil getting down into the cylinder on that one. We'll have a look a bit later on. What's it? Oh, right, so this here was loose. I've not touched that. That was loose already. This nut here onto the injector is very tight, so I'd suggest it's got a damaged thread. It doesn't want to come undone. This one isn't much better. So I've just come to undo the fuel filter assembly, and it's It's not actually bolted on properly. And again, the nuts are loose. As I said, we'd rattle on with the strip down unless we came across anything that was cause for concern. Nothing of cause for concern in the cylinder heads. It appears the engine has had service exchange cylinder heads in the relatively recent past. So apart from being a bit more dirty than I'd expect for a 80 hours of use engine, they're mechanically okay. So here we are with the cylinder heads off. Only thing I've spotted is this cylinder here and this cylinder here look like it's been a bit washed out. There's areas of clean cylinder head where all the others are carboned up. So something's been going on here that's not as it should be. Coming over to the block, as expected, the liners all appear to be in good order. Haven't spotted any scores yet. Obviously we'll have a much closer look at them once it's off and a bit cleaner. But it looks like it's had a service exchange block as well. One thing we have noticed is it clearly has a set of pistons that have been used in something else before. Because, for example, this is cylinder 4, but this piston is marked number 5. This is number 3, but this piston is marked number 6. So at some point, these pistons have either been off this engine and have been muddled up and not put back where they came from, or they're out of another engine. So having a better look at the pistons, since the last bit of video you've just seen, yes, they're definitely a mixed set of pistons out of other engines. So this one here you can see is marked 1. And you can see it's marked with the engine number 171719. Now this is cylinder 1. Cylinder 2 is marked 148951, which is the engine number that's stamped on the crankcase of this engine. So this is a piston that came from this engine originally. And you can also just about see it's stamped number 2 here. Then, like I said earlier on, number 3 is again stamped 171719 and is actually stamped on the crown number 6. So it's a used piston out of another engine. You can see there's also damage to the edge of the crown of the piston just here. Then we come across to number 4, and number 4 is actually stamped number 5 and again says 171719. So cylinder 1, cylinder 3 and cylinder 4 have pistons from a different engine. If we come round to cylinder 5, you'll see this piston is again marked, I think it's number 5. Yes, number 5 and 148951, which is the number from this engine. So cylinder 2 and cylinder 5 have pistons that were originally from this engine. And then when we get to number 6, you'll see there's quite a bit of damage to the crown of the piston. Well, now I've cleaned the carbon off. And it is marked 148951. So this is an original piston from this engine. So 3 of the pistons are from a different engine. 3 of the pistons are from this engine. But from the numbers on the crown of the piston, all of them are the earlier 14:1 compression ratio pistons, not the later 15:1 type. Also, things I've noticed is this water jacket ferrule is actually damaged. The ferrule in the middle is broken and the O-ring has obviously been distorted, and because of that it has been leaking, and you can see the corrosion on the top of the gasket where the water has been passing out into the top of it, so that's obviously not right. And this odd selection of serial numbers on the pistons has led me to look at the engine itself, which I'd forgotten to do at the beginning of the video. So The number on the crankcase, and as I said, 3 of the pistons, so 148951, that is sort of late 1965, so between July and December 1965, which would actually make the bottom of this engine LX, not LXB. This engine's also a bit of a mongrel because, as I say, 3 of the pistons and the crankcase are late 1965, but the number just here, hopefully if you could see it, is 229252. Well, that is actually a late 1982 serial number, so that means that at least the insertion plate, if not the cam box, is off of an engine from 1982. You then come round the far end, and the serial number on the flywheel is 138321, which would make that early 1963, so between January and June 1963. So the flywheel isn't original to the crankcase. Some of the injector pump, if not the whole cam box, is off of a much later engine. 3 of the pistons are the originals to this engine. So they date from sort of 1965. So weren't replaced at the time this had a new block and new heads. And also the other 3 pistons, which I mentioned have got 171, 719, they would be from early 1970. So the engine's made up of quite a few bits. Not that that's necessarily a problem, but it's just interesting because it appears that the bottom end of this engine actually started life as an LX, not an LXB. So anyway, we'll progress on so that we can get the block lifted off. And then inspect the skirts of the pistons and the piston ring grooves, etc., like that, to see what we've got there. So here we go. Here's the inside of the main oil pipe that goes from the oil pump up to the oil filter housing, and you can see nice grey metallic-y paste there, so it certainly ground something up. Okay, so the proper Gardner drive shaft for the alternator has a spigot on the ends that sits in a bush here, and also should locate into the end of the alternator. This one has been made up and doesn't have that either end, so we'll need to do some work there to correct that so it's all supported properly. Okay, so before we get into taking the cylinder block off, I'm just going to check the bumping clearance on all of the pistons. So that's the clearance between the crown of the piston and the underside of the cylinder head. Just so we have a vague idea of how much has been machined off of this block in the past. So I've just done number one and number 6. Number 1, the crown of the piston is 0.95 of a millimetre higher than on number 6. So we'll just check the others as well, but there's quite a discrepancy between 1 and 6 on piston height. Obviously not super accurate because the crowns of the pistons are a bit dirty, but we just wanted to know roughly how the pistons sat in relation to the top of the block, just for a bit of guidance when we come to put the engine back together again as to what we think we might be needing to put underneath it as shims. So anyway, we'll move on to lift the block off. This number 6 piston, as you turn the engine off, you can hear it scraping. So there's something not happy here. Maybe we've got a broken ring, or this is the one that's got a bearing problem. There we go, there's the block off. Okay, so take the pistons off, and I think we've definitely got big end bearing problems. So this is number 6. There's no bearing left in that one by the sounds of it. There's a little bit of vertical play in that one. A little bit in that one. That one seems okay. That one seems okay. And then there's loads of play in that one. So we'll carry on, but I'm pretty certain we've got more than one failed big end bearing. Getting back onto pistons, another thing that's worthy of note is I mentioned earlier in the video that 3 of these pistons carry the original engine's engine number, and the other 3 carry the engine number off of a much later engine, so 1970 instead of 1965. If you look here, you will see around the gudgeon pin hole a difference in design between 3 of them and the other 3. So although all of these are 14:1 compression ratio, 3 of them are earlier LX type pistons and 3 of them are later LXB type pistons. Now, in the manual, it states that these must not be mixed, and that is because they differ in weight. So the limit for weight difference between each piston is 1/4 ounce or 7 grams. And what you'll see here is if I pick up this very first one, which is one of the later type pistons, you will see it weighs in at 2,408 grams. And if I pick up another one of the same type, 2,404 grams. So obviously within that 7 gram difference in weight. However, if I pick up this one, which is obviously one of the ones that was original to the engine, it's the different type, you will see that this one is 2,585 grams. And obviously that is well more than 7 grams difference in weight. So another thing worthy of note on this engine is that this has got 2 different types of piston, which shouldn't have been mixed in the engine. More iron paste. Okay, so we've moved on a bit as there was nothing really to tell with what we've seen so far. The flywheel is off at this end, and then up at this end we've removed the pulley off the crank and removed the front cover. We've also removed the camshaft. Nothing particularly of note there. It all is pretty good. There's a couple of the lobes have got a bit of wear on them, but we can sort those out, that's fine. The only thing we found of real note is the water pump drive. Now, if you've watched the videos on the last LXB, you would have heard me say these are drain holes and should be at the bottom. However, if you look at all this grease here, and there isn't any up here, that was installed upside down. So because of that, the oil can build up in around the bearing behind it because there's no drain holes. And then obviously it's been leaking out into here, as you can see. So in its installed location, you can see there's all of this muck down the side of the crankcase and along. So that was all caused by that water pump drive being in upside down. So as I say, that's the only thing really worthy of note since the last bit of video you saw. So we're now going to move on, unbolt the sump. We're going to stand the engine up on its flywheel end bell housing, and then we can take all the oil pipe work and com rods out. Okay, so that's the sump off. There's some grey metallic-y gunge in here, but there are no big lumps of anything, so we'll get the engine up on its end and see if we can find what's caused the bearing failures. So we now have the engine stood up on end, and after clearing up the oil that's come running out of it everywhere, just thought before we go any further we'd quickly check the end float. I'd forgotten to do it before we tipped the engine up on end. So obviously crank is by gravity fully the other way down towards the flywheel. So let's see what we've got. Just zero that. So that's 0.32 of a millimetre. So that's over 12 thou of end float this crank has. Okay, so we've removed all of the bolts and fasteners from the main gallery for the main bearings. So it's ready to come off. Obviously, as we're looking for the cause of the bearing failures, we're going to inspect all of this in a second once it's off for blockages, broken seals that might have been leaking, that kind of thing. So we'll check all that in a mo. So we'll get it off, come back once it's on the bench. So first up on looking for causes of the bearing failures is the seals between the main bearing caps and the oil pipework. So we've got very squashed flat seals, but they are all here. There doesn't appear to be any damage, so there's 4 of them here. And then the lower 3 are in the pipework. So they're all present. So before we move on trying to find what's caused the bearing failures, I'm going to strip all this apart. There is O-ring seals in all of these. We've had it before where they failed, so like that one there, there's no grip on the O-ring at all. That one's a bit better. O-ring is present in there. That one's not too bad. But as I say, there was absolutely no friction there between O-ring, so that would have been leaking. On that one, same there, nothing. So those of you who have watched the video of the last LXB, this was the cause of the low oil pressure issues that the last engine we did have. Basically, these seals over the years go hard and fall to bits and lose their grips, because like here, absolutely no friction there between the O-ring and the tube. So as this tries to get up to oil pressure, it will be leaking out around every one of these. Again there. Again there. A little bit of friction on that one. Little bit of friction there. Nothing on that one. Nothing on that one. So I'll just check that I can see daylight down through all of them. They're okay. That's okay. That one's okay. So is that one. Both clear. Both clear. So we have no blockages, but a lot of these, when they're pushed into their O-ring seals, had absolutely no friction there whatsoever. So I would suggest, as we've seen before on others, that these would have been leaking oil past the O-ring seal and therefore losing oil pressure. And here we are with all of the com rods out of the engine. As you can see, all of the bearings are in very poor condition. Far left hand end is number 1 to number 6. So if we look at number 1, obviously very well chewed up. Number 2 and number 3, are still quite badly chewed up, but obviously not as bad as number 1. Again, number 4 is quite bad. Number 5 is even worse. And number 6 on the upper shell here, where the others are very chewed but still on bearing material, number 6 has actually gone right through to the backer. Now, these are original shells, so I would hazard a guess these weren't changed when the engine was rebuilt last. The crank is also in pretty poor condition, as you could expect. So this is number 6's journals. Many British roads are smoother than that, and that's saying something. Number 1, again, this is quite badly chewed up. I mean, this is very, very rough here. The other journals, all of them have scoring and marking on that can be felt. That's probably the best of all of them. Number 3 there. This one's very well chewed up. So is that one, very rough. Now, this engine had a Gardner service exchange plate on it, which said that the big ends were standard size at that point, and the main bearings were 20 thou under. The big end bearings we've taken out are all standard size, so the engine hasn't been reground again since that was put on. But one thing we have noticed that is quite of concern is this stamping here in the bottom of the block. So this is saying that the main bearing housings, the bore around the crank, actually in the crankcase, is 10 thou oversize. Now, that's not something we've personally seen before on these, but I would hazard a guess that finding bearings that have an undersize to be able to grind this crank and an oversized OD is going to be very fun, if not impossible. So, although we could possibly grind the crank, I've got a feeling when we start measuring this up, this will actually scrap this crankcase. So anyway, we'll carry on, get the crank out so we can see all of the damage. But it is starting to look like we'll be needing to start from another base engine. And here we are with all the bearing caps off for the main bearing. So this end here is at the forward end of the engine. This is the flywheel end. As you can see, they've started to pick up quite badly. This copper area that you can see here is pretty common when you take one of these to bits that's done a reasonable amount of miles, that you'll see this one, and this one not looking too bad. And this one, and this one showing copper. So that's not to be unexpected. But not that you can probably see it very well on the camera, but there are big ridges in these ones that I can see. So they weren't a million miles off of having failures like the big ends. The upper halves of the same shells, as you can see, they're quite well scored up. So with this engine, unfortunately, it looks like the crank is quite badly damaged, and number 1 and number 6 big end have been very cooked, and you can see the heat marking on the crank. So I personally wouldn't reuse this crank. We'd be looking for a new crank. So that's what we would have done. New crank and replace the com rods that go with them. Unfortunately, because of this, we have just checked. All of these main bearings are 20 thou under, which is what the plate on the old Gardner plate on the side of the engine says. So the 20 thou under for the journal size, but they are also 10 thou oversized. So the outside diameter of them is 10 thou bigger than it should be. So that is going to make finding bearings for this engine quite difficult. So we will have to have a conversation with the owner as to whether to put the effort into sourcing a crank, com rods, and oversized OD bearings to go with it, or whether it'll be more cost effective to start with another core engine. So next video on this engine, you will see which route we're going, whether that's another core engine or the rebuild of this one. So during this teardown, it would be our opinion that the cause of the failure of this was loss of oil flow to the crank, which has obviously chewed all the bearings up. But we think that the cause of the failure for this was £10 worth of rubber O-rings on the main bearing gallery pipework. So basically you were losing all your oil flow and oil pressure out round all of those seals. I hope you've enjoyed watching the teardown, and we'll see you again soon. If you've enjoyed watching this video, please consider liking and subscribing. Thank you for watching, and see you next time.